Hello. Yes, we welcome you back to PSSB, Physical Sciences. Silver Bullet and Smith Richard here. Yes, today we are looking at this question. It says, calculate the magnitude of electric field at point X. Point X, which is that distance from the nucleus of a hydrogen atom, and state its direction, whether it's outward or inward. Okay, how do we go about this? Here you have to remember that the hydrogen atom is very important that you know the picture of hydrogen atom. Hydrogen atom, on assuming that we are taking the Bohr's atomic model, in the nucleus of hydrogen atom, there's only one proton. That's why most of the times we use it, because it is very simplified. One proton, one electron. So in the nucleus, we have one proton. Okay, and here they say that we are going to calculate electric field at a distance x, assuming that that's the point under our consideration. And we are given the distance, which is 4 times 10 power minus 13 meters. And we know the charge on the proton. So when you come here to look at the data, the charge on the proton is the same as the charge on an electron. And it is 1.6 times 10 power minus 19 coulomb. Okay. What else do we know? We know R. And what is the distance? The distance is 4 times 10 power minus 13 meters. And what else do we know? We know K, our normal K, electrostatic constant. So with this information, I need you to take you somewhere so that we can have this before we start with the question. I want you to remember that we said electric field at a point is force per unit charge. But you have to remember that according to Coulomb's law, force is equal to kq1 q2 over r squared. So when you substitute for that F, what are we going to get? We are going to get E equals to F, which is K Q1 Q2 over R squared divided by Q. This one can be Q1 or Q2. Suppose we make it Q2. So next step we are going to have is going to be E equals to K Q1 Q2 over R squared times 1 over Q2. And what do we do? You cancel out this and this. And from there, what do we get? You get your E as K Q1 over R squared. Now, I want you to tell you that this is a fundamental equation in electrostatics. That's how it comes about. So we are going to be applying it. You should start applying it. It's close to impossible for a question paper to come without it. So now we are back to the question, and we are looking for what is our unknown here. They said electric field, so our unknown is E. And when you look at the data we have, the data suggests that we are going to use this equation. which says E is equal to KQ over R squared. And when you look at our E, what is K? We know it. And our Q is that. And our distance is known, all squared. And we get our E. So there we are. This is the magnitude of the electric field at that point. Very strong. It's to power 15. You have to remember that. Now we come to this part. Is it outward or inward? Here you have to remember something. We said that at the core of the hydrogen atom, we have a proton, which is positive. And you have to remember that we use a positive charge to indicate direction. So if you have a positive here and a positive here, and remember, this proton is not the one which is moving, it's this one, the testing charge, which is going to be moving. Does it move inwards or outwards? The answer is outwards. So then comes the next question. It says, calculate the force exerted on an electron placed at X. Okay. So let us look at the information you have here. What do you know about X? We know E at X, and it is 9 times 10 power 15 Newton per Coulomb. That one is known. What else do we know? We know the charge of our electron. And what is it? It is 1.6 times 10 power minus 19 Coulomb. Okay, with that information, then what do? You quote the right formula. And the formula is, according to the data, it's going to be equals to F over Q. You have to remember that our unknown here is F. So when you substitute in, what do? You have your E, which is 9 times 10 power 15. And our F is wanted, but you know the charge, which is 1.6 times 10 power minus 19. So what do here? You're going to get your F. Your F is going to be 9 times 10 power 15 times 1.6 times 10 power minus 19. So what you get out of that is going to be the magnitude of the force. So that is what we have. Yeah, the force which is experienced by an electron placed at X is 1.44 times 10 power minus 3 newtons. And with that, would like to thank you for your time. The channel is PSSB. Yes, we are not going to get tired of reminding you to subscribe, to share, to like, to comment. Yes, we believe this is going to be very useful to you. See you next time. Bye-bye.